Alright, this is Algebraic Reasoning Review 1.6 to 1.9. Problems number 11 through 17. Okay, basically these are just reading the graph to figure out what's going on. Alright, and remember these things, the graph actually goes forever in both directions. But it's really, we're talking about the domain of the domain and range, which is your x values and y values, of the function versus your actual real life situation here. Alright, so what is the domain of the function? The domain of the function is all real numbers. Alright, so the domain of the function, that's the actual equation. And the domain is always all real numbers, unless there's a place where the equation kind of poops itself, which we'll come across those later. The range of the function, well, you just kind of got to look at it and say, well, what's it doing? It's going down forever, and it's going up forever. Well, if it's going down forever and up forever, that again is everything. Alright, so you got to find the boundaries. So in this case, it's also all real numbers. Let's make that a little cleaner. So that's the function. Here's a graph of the situation above. What would be a reasonable domain for the situation? So basically what they're asking, what is a reasonable domain? What is a real life x value that you can deal with? Okay, remember we're making cuts. We got a piece of cardboard, a 16 by 16 piece of cardboard, and we're making cuts in the corners. Well, the smallest cut we can make is a 0, so that's probably the smallest thing we can actually do. You can't make a negative size cut. It's kind of like a ruler. You have a negative number on a ruler, you can't do it. Alright, the biggest cut we can make, well, if I go 8 in here, and if I go 8 in here, I've pretty much met in the middle, right? So can I make bigger than an 8-inch cut? No. So from there to there is probably, no, it's not probably, it is the acceptable x values for the situation. It is the acceptable domain. So my domain goes from 0 to 8. Okay? What would be a reasonable range? Okay, so if domain is x, range is y. So if this is my acceptable domain, then pretty much any y value within those parameters is an acceptable y value. So the y's go from 0. The highest y is actually way up here at 303.407, which we'll just take 303.4. Alright? Why not? So the range goes from 0 to 303.4. Totally forgot what I was saying. Anyways, so that's your range. I basically limited my domain to this region down here. And if these are my only acceptable x values, then if those are my only acceptable inputs, then these are my only acceptable outputs. Alright? This one's out over here, this one's out over there. Just let me clean this up a little bit. Alright. Where is a local minimum and maximum? Okay, well, a local minimum and maximum, remember that's where the graph turns around and goes the other way. So the graph goes up like this and turns around, well then there's a maximum. Goes like that, turns around, there's a minimum. Well, so the local max is at, I'm just going to call that 2.7 and 303.4. The local minimum is at 80, which I know I covered it up with that guy, but that's your local minimum. Last but not least, what does the domain represent? Well, here's another. Remember, your domain is your x value, so you can think of that as what does x represent? Well, if you recall the situation, we're making cuts into a piece of cardboard. So X domain represents the length of our cuts. And you can just go back up the table up higher on your page and look at that. Your X value is your length of your cuts. So that's what your domain represents. What does the range represent? Okay, range is Y. So look at your table for the Y. What does the Y represent? Well, Y represents the area. So range represents the area of the box. And that's it.